Hello, this video is an introduction to circular motion. We can call it circular motion 1, so it's pretty obvious it's a start. Okay, so let's draw a circle. First of all, there we go. It's freehand circle. And let's imagine we have a mass m rotating around in a circle. Now it's as if you were swinging a mass on a string above your head, so it's often known as a horizontal circle, and there's only one force acting on it. So this is the center of the circle, and call that the string there connected to the mass. So that's going round and round, and let's give the mass a velocity of v. Now this is and call this C as the center. Okay, so it's going round and round in that direction. Now what is happening? What formula are associated with this? So first of all, let us talk about the time period. Now the time period t. The time period t is the time it takes for an object to go all the way around once. Okay, that gives you the time period. Then we can talk about the frequency. The frequency f. Oh, by the way, the time period is usually measured in seconds, so seconds, and the frequency f is the number of revolutions per second. How many times it goes round? It's back to the beginning again in 1 second, and the frequency is given in the units of hertz, which is the same as seconds to the -1. And those two letters are linked by the formula that the frequency is equal to 1 divided by the time period, and equally the time period is equal to 1 divided by the frequency. Okay, so we've got v is its velocity, m is its mass, and let's say if c is the center, let's say if r is the radius, so this is from center to where the mass is, that is r. If r is the radius, we also have something called the angular velocity, omega. Omega is known as the angular velocity. Okay, and the angular velocity is in radians per second. Okay, and we're going to rub the board, and we're going to talk a little bit more about the angular velocity now. So here we have our circle, particle, mass m, velocity v, on a string, radius r. I haven't written down c anymore for the center. Now we're talking about omega, the angular velocity. Now the angular velocity is measured in radians per second. It is related to the rate of change, or the change in angle. We'll call that theta is angle, divided by the change in time. And when we expressed it in a non-calculus version, sometimes I like to remember it as omega equals angle divided by time. Okay, now the angular velocity at every point, so imagine that's a string going round and round like that. The angular velocity at every point on the string there is going to be the same. So it's going, so if this is, it's marking out an angle theta there, so this is the angular velocity at every point on that string is going to be the same. However, the velocity will change. The further it is away from the center, the faster it is going. And in fact, the linear velocity v is equal to the angular velocity omega multiplied by the radius. Okay, and a little bit more about radians, and of course there are 2 pi radians in a circle is equal to 360 degrees. Okay, now next thing we'll look at acceleration. So here's our circle again. Here's the string. Okay, now there's going to be a force. If this is a string, there's going to be force acting on this mass, and the mass, from the mass's point of view, it will feel the force T acting towards the center of the circle from the mass's point of view, and that for our horizontal circle is the only force it will feel, and therefore and that is the resultant force. Therefore it will feel an acceleration. It will feel an acceleration towards the center. So that's what the mass will feel, acceleration towards the center. And the acceleration is given by, for centripetal motion, this is a centripetal resultant force is a resultant centripetal force. Centripetal means acting towards the center, and the acceleration is given by the velocity squared, that's v, divided by the radius, that is the radius r. And then if we look at the complete equation, we have the resultant force acting on it from Newton's second law. We have F equals ma, and we can apply that to centripetal, to circular motion, is we have F equals m times the acceleration v squared over r. That is the resultant force. Now if we apply it to our example, the only force acting on there is the tension. So therefore, in our particular example, we can say that the tension in the string is equal to the mass of the object multiplied by the velocity squared over r. And I think I'll leave it right here.